Hey everybody, Matt Morgan here. In this video, we're going to talk about calculating and applying molar mass. And as an example, we'll use some problems from Wiley Assignment 5QA. We'll talk about finding molar mass, using molar mass to convert between grams and moles, and converting between grams, moles, and molecules. The examples we'll use come from exercise 5-1 in Wiley questions 10, 11, and 12. So here's question 10. What is the molar mass of carbon dioxide in grams per mole to four significant figures? And our choices. First, we need to know the formula. Carbon dioxide is just spelled out in words. Some of these can be challenging. Carbon dioxide, carbon, two oxygens, pretty straightforward, but it's good to know your chemical naming. Next, what we'll do is look at the periodic table for the atomic masses of carbon and oxygen. I see carbon, 12.01, oxygen, 16.00, rounded up. I add those together. One carbon, two oxygens, according to the formula. 12.01 plus 2 times 16. Check my math on this, but I get 44.01. Okay, this problem, pretty easy. It's good to know how to quickly and accurately calculate molar mass because we'll be using it for these next two questions. Molar mass allows you to convert between grams and moles. If you're given grams and want to go to moles, given moles want to go to grams, your conversion factor is molar mass. In the next question, they ask for the mass of 2.5 times 10 to the minus 3 moles of carbon dioxide. We will be using that molar mass we calculated in the last question to answer this question and question 12. Remember, the molar mass is our gateway. It allows us to convert between grams and moles. In this case, we're given moles and we will calculate grams. So our tools will be the given information, the conversion factor, our molar mass, and we will use dimensional analysis. Our target unit is grams of carbon dioxide. So we're given 2.5, 10 to the minus 3 moles. Grams is our target unit, so we'll go the 44.01 grams on the top, which tells us to put moles on the bottom. And that's exactly what we want because we want moles to cancel. Moles cancel, we're left with our target unit, grams of carbon dioxide. We won't apply any more conversions because we are at our target. Now we'll do our math. Numbers on the top get multiplied, numbers on the bottom get divided. Check my math on this, 2.5 times 10 to the minus 3 times 44.01. I get 0.11. I use two significant figures because my given information is two significant figures, and that is one of my answers. The final question, they ask for the mass of one molecule of carbon dioxide. This requires a little more thought because we won't be able to do this in a single conversion. We will have to use two steps. We are given one molecule, the target unit is grams, and we can't do it all at one time. We're going to go through moles. We also know that one molecule is very, very small. Looking at our given choices for answers, we can eliminate two of those choices right away. Okay, 10 to the 25th, 10 to the 22nd grams, those are huge amounts, and we know one molecule cannot weigh that much. So we convert molecules to moles by using Avogadro's number, 6.02 times 10 to the 23rd. Our target unit, once again, is grams. So we set up our dimensional analysis grid, start with our given information, one molecule of carbon dioxide. Applying Avogadro's number, I'm putting 6.02 times 10 to the 23rd molecules on the bottom, so that cancels. I have 1 mole of carbon dioxide on top. Now we can use the molar mass we calculated earlier to convert those moles to grams. 44.01 grams of CO2, our target unit on top. 1 mole on the bottom. Now, let's see what cancels. Molecules of CO2 cancel, moles of CO2 cancel, and we are left with our target unit, grams of carbon dioxide. Once again, we do the math. Numbers on the top get multiplied, numbers on the bottom get divided, and I come up with, please check my math, 7.31 times 10 to the minus 23rd grams of CO2. Feel free to pause the video to do the math yourself and check my numbers. And if you come out with that, that is one of our choices. So in this lesson, we found molar mass by adding the atomic masses. Molar mass allows us to convert between grams and moles, and we did that in problem 11. And then in problem 12, we used Avogadro's number to convert between the number of molecules and moles. Dimensional analysis applied all of these conversion factors to solve the problems. And that's it. Go forth, convert grams to moles, and solve chemistry problems.